Hello. For our final week of lecture, we're going to be looking at evaluating job demands of the upper extremities. If I were to ask you to answer this true or false, work-related upper extremity, which we'll abbreviate UE, musculoskeletal disorders, or MSDs, so UE MSDs, are caused by occupational risk factors, would you answer that true or false? And you'd probably go back and say, well, our MSDs, we know that they have several potential sources, not all caused by work. They could be caused by the health conditions of the employee. For example, if they have a disease such as diabetes, then you know that their nerves are compromised, and so they're more susceptible to nerve-related disorders such as carpal tunnel syndrome. And so the health condition of the employee has a role. Secondly, you know that an employee can be doing something outside of work, their hobbies or activities, sports, carpentry, those types of things, and those can relate or can contribute to upper extremity disorders. And then your third source would be work-related risk factors, and so it's could be those three. But whenever we add in the work-related upper extremity MSDs, those do definitely have a work component, and they are caused by occupational risk factors. And so this statement is true. If it is a work-related upper extremity musculoskeletal disorder, it is caused by occupational risk factors, and so your risk factors at work. Second true or false statement. If exposed to risk factors, the worker's risk of MSD increases. And you know, if you have 10 employees on the job doing the same job, one employee develops an MSD, you're searching, is it a work-related, a job-related cause? And you might think, well, the other 9 people haven't gotten it, so maybe it's not work-related. But you have to realize that we all have different levels of susceptibility depending on our health, and so we can say that if they are exposed to risk factors, a worker's risk of MSD increases, but it doesn't make it a definite. And so some people are more susceptible, some less. So some may develop through this exposure to risk factors. Some may develop an MSD, whereas other ones will not over a long term. So we've been talking risk factors. What do I mean by risk factors? Typically, OSHA considers that there are 6 physical risk factors. The 3 primary are force, repetition, and awkward posture. And hopefully you've learned this in an undergrad, either human factors course or ergonomics course. And so you come in with some exposure to this. Your lesser three not as common. They're not don't have exposures as frequently in all of your jobs, but your lesser 3 are contact stress, and some of you might call this mechanical pressure, mechanical stress. Those are the sharp edges. Vibration, so exposed to vibrating tools, so hand-arm vibration, or it could possibly be whole body vibration if you're in a vehicle or sitting on or near a vibrating surface. So contact stress, vibration, and cold temperatures. Some people just say temperature, but it's really cold exposure. So you need to warm up your muscles so they're not cold, and then the cold outdoor temperature increases a person's risk. So those are the 6 risk factors. Sometimes people will throw in static postures. I usually use a static posture as a variation of an awkward posture, or a long-term exposure to an awkward posture or awkward posture repetition effect. Some people will throw in lack of rest, but that's really a characteristic of repetition or exposure. So these are your 6 risk factors. And then for this part of the course, we're going to be looking at 2 tools to evaluate the exposures to determine the likelihood of an upper extremity musculoskeletal disorder developing. The first tool we're going to look at is the ACGIH TLV for hand activity. In this, if you've had any industrial hygiene course, undergrad or grad level, they've probably talked about the ACGIH, and so that's the American Conference on Governmental Industrial Hygienists. Sorry about that. TLV will be your threshold limit value. This method, when we were characterizing the different methods, this method is semi-quantitative, so there are some things to be measured, so semi-quantitative. It also looks at long-term upper extremity exposures. You can find information on this TLV in page 162 to 164 of your textbook. For the ACGIH TLV for hand activity, it's looking at trying to predict risk for MSDs of the hand, wrist, forearm, and elbow. And so it's the upper extremity elbow on down to the hand. We have a series of or possible set of upper extremity MSDs that you might have run across, be familiar with. One would be in your fingers, would be stenosing tenosynovitis. This is a trigger finger. De Quervain's disease is trigger thumb. Okay, so those are some disorders that can happen in your hands, in your fingers. We obviously have the most famous carpal tunnel syndrome, and famous because it is the most common upper extremity MSD that you'll run across. About anywhere from 1 to 10% of the working population is thought to have carpal tunnel syndrome. And that occurs, it's a nerve compression in your wrists. There's potential for lateral epicondylitis or medial epicondylitis, and that's a tendon disorder in your elbow, so where the tendon attaches to the bony part of your elbow, you might develop an epicondylitis. There's another disorder, radial tunnel syndrome, and that happens very near your elbow epicondylitis, but it's about 2 centimeters below, and it is a nerve compression where you're compressing the radial nerve. And then finally, another one that you might run across, it's thought to be the fastest growing upper extremity MSD, and that is cubital tunnel syndrome. And it's compression of your ulnar nerve in your elbow, so right near your elbow. So cubital tunnel syndrome. Okay, so we're looking to predict MSDs of the hand, wrist, forearm, and elbow. This method is for monotasks only, so it's very limited. The industrial hygiene community said they wanted to start with, when they were jumping into ergonomics, they wanted to start with what was known, what they could prove, what was documentable, and then later on they would add and expand. But for now, that it focuses on monotasks only, which means it's looking at repeated, very similar motions. You're doing the same thing over and over and over again, with a time constraint that you're exposed for more than at least 4 hours a day. So you're doing the same task 4 or more hours a day. It considers, again, starting small, considers only 2 of the risk factors. It considers repetition/duration, so your repetition factor, and considers force. This is a 3-step process, so 3 steps. The first step is to identify the repetition/duration factor. And so really you're looking to try to find the activity level of the hands to find an HAL, a HAL rating. Ratings on this, and ratings meaning that you, the observer, will be evaluating this. The rating should be based on an average representative work cycle. It's not the fastest, not the slowest, but it's a typical. How do they typically work? One way to rate this is to use the scale 0 to 10. And as you're observing an employee on the job, you're looking to pick out a rating from 0 to 10 with the help of some of these definitions. The first part of the definition is the repetition factor, and you're looking at if at the 0 level hands are idle most of the time, 2 would be slow motions, 4 slow steady, and so on up to a level of 10 is rapid, steady, or continuous motions. Okay, so this is your repetition factor. So as you're observing an employee, you're simply rating them 0 to 10. If you want to bring in the duration factor, the bottom one is the duration of exposure. You go from a value of 0 of no regular exertions up to, for example, an 8 is you have rapid steady motions but infrequent pauses, and then 10 they're working so fast they have difficulty keeping up. Okay, so you're rating while observing. If you want to pick a number in between, it's not quite 0, not quite 2, a 1, you can do so. So the definitions or the text tie-ins to the scale are meant to direct you better defined. If you don't like that, we've had experience with a visual analog scale in our previous chapter when we were looking at psychophysical methods. And so you, the observer, could use a visual analog scale rated from 0, meaning no or almost no exertions, up to a level of 10, and that would be the most possible exertions that the employee could produce. And so if you don't like the previous scale, you're welcome to use a visual analog scale. Okay, so that's step 1. On step 2, you're going to be looking at the force factor, and for this one you want to find the normalized peak force level of one exertion only. I've put that in red because this is a very common mistake that people make. You're only looking at one exertion, so one exertion. And you're looking at a peak force, so the peak force of one exertion. This will be a regular normal exertion. So a common exertion, it's not the most they ever produce. It is a normal part of the job. Okay. For example, if I were writing the sentence, I love dogs, bang, I love dogs, bang, I love dogs. Out of that, you're probably, well, what is the peak force that I would be exerting? And I would probably say, well, on that bang was meant to indicate that, well, I'm pounding, I'm banging, I'm something. And so your peak force might be that part of the explanation point, that I really banged the screen. Okay. So looking at, out of all that activity, what's your peak exertion? For step 2, you're looking at a force factor, and so you're trying to find the normalized peak force, or NPF, of, again, a typical high exertion. To find that, you have several possibilities, and you can out of these possibilities, you can rate it using the scale you feel most comfortable with. One is you can have the operators themselves, so the employees, you show them the Borg CR10 scale, and they pick out, I think I'm working at a 2. Okay, so to find the normalized peak force, you can have the operator indicate what level of force they think they're exerting. You can also have an operator or observer rated on a visual analog scale, such as the 0 no force up to the 10 greatest force imaginable. Okay, so the operator can do this. You can have them mark the scale, or you can, based on your observation of the task, you can also rate how much force you think they're exerting. Okay, so those are options. There is another possibility described on page 164 of your textbook that talks about a percent MVC, or percent maximum voluntary contraction. And it is simply, it's an equation. Your percent MVC is equal to the grip. For example, if you use grip strength, the grip required in a task, so the grip required, divided by the maximum grip strength. And so your grip strength max. And so it's simply a percentage, how much you're exerting out of what you have possible. For example, in this one, percent MVC, if a person, if a job required they exert 10 pounds of force, and you measured their strength with a dynamometer, grip strength dynamometer, if they had 90 pounds of force, then that would be simply calculated 0.11, or they're exerting 11% of their maximum strength. So if you can measure strength, if you can get an estimate on the strength that they're exerting versus their maximum possible, you can calculate the percent MVC. So for example, if I were working a word problem such as in homework, a roulette dealer's assistant sorts losing bets and stacks chips by color. So you've all been to casino. There's lots of chips floating around. They eventually have to be sorted if you're doing this manually. Sorting is continuous using steady motions because there's lots of chips while bets are placed and the wheel is spun. During an infrequent lull, the assistant floats to a new table to continue sorting throughout and he works for 4.5-hour shift. I want you to evaluate the upper extremity musculoskeletal disorder risk. And so using the hand activity level TLV, you have to identify step 1, the hand activity level. And so we have some keywords such as he's using steady motions, there's an infrequent lull. If we went back to our table where we were trying to evaluate or trying to determine what the hand activity level is, we have steady motions and frequent lull. So steady motions and frequent lull, which means that's probably an HAL, hand activity level of 6. So going back, this is probably a 6. Looking at our normalized peak force, NPF, well, they're chips, casino chips, and so they're pretty light. You're looking at a peak. A peak is probably whenever you have a stack of them, and so you're thinking of a stack of chips, evaluating the peak force. You could ask the operator. You can ask the operator using this scale. You can ask the operator using visual analog scale. But say they pick a very weak. They think they're working. The force is actually pretty weak. Okay, so once you have those evaluated, your next step in this, you've done step 1, step 2. Now step 3 is to calculate a ratio. Ratio is equal to the equation NPF divided by 10 minus HAL. And so our ratio is equal to, our NPF is equal to 1. Our 10 minus HAL is 10 minus 6 is equal to 1 over 4 is equal to 0.25. Okay. We have an action limit of 0.56 and a TLV of 0.78. And so we can see that our action limit is here is 0.56. Our TLV is here, 0.78. And so we can see that we fall somewhere right here below the action limit, below the AL. And so in this level, MSDs are unlikely. MSDs are unlikely. It's below the action limit, below the TLV, so MSDs are unlikely. Okay, so we don't expect to see MSDs in this chip sorting task. Also not provided in your textbook, I took this from the ACGIH TLV, is a graph that you can use to evaluate it. It has HAL on the x-axis, the peak force, the normalized peak force on the y-axis, and so we had a hand activity level of 6. We had a normalized peak value of 1, and so that places us right here on the graph. You can see that's in the green zone. Green zone, again, below the action limit. In the green zone, MSDs are unlikely in most people. If we were in the yellow zone, it's possible in some people. And then if it's in the brown zone, and I guess that should be red, but the TLV has it in brown, MSDs are possible in many people. And so you want to apply your controls, engineering controls at that level. Okay. So the hand activity TLV considers two risk factors only, repetition and force, and they leave you with, if you have exposure to the other risk factors such as awkward postures, cold tempers, or vibration, contact stress, for those you'll want to use your professional judgment and apply controls or control the other risk factors if they're present to any extent.